So let's go ahead and discuss the fundamental theorem of calculus and see how that actually gets applied later on in some of the AP classes for both AB and BC. Let me go ahead and select a pen color. There are two parts to what's known as the fundamental, so FUN, fundamental theorem of calculus, right? So in this particular case, when we deal with the fundamental theorem of calculus, we abbreviate it as FTC, and normally there's a part one and a part two. It's not important to necessarily differentiate between those two in terms of names, but it's important to know that there are two versions of it. For me, I like to start with the second version first. So that is the integral from a to b of f prime of x dx will equal f of b minus f of a. Now, you'll see this written in a lot of different ways, but this is essentially what the fundamental theorem of calculus is. If you have this left-hand side over here, then you will end up getting this right-hand side over there, all right? Occasionally, I'll write this in yellow, you'll have something along the lines of integral from a to b of perhaps lowercase f of x and dx like this. They might write it like this. And then you'll see something along the lines of capital F of b minus capital F of a. This is exactly the same, but you have to go through one more step because I had to define what the relationship between capital F and lowercase f actually are. So you would say that, oh, yes, if I take the derivative of capital F, I end up with lowercase f of x, right? So again, you can see either of these. They're both considered the fundamental theorem of calculus part two, but I generally tend to stick with the first one. Then on the other hand, there is part one. So I'm going to walk you through it doing the following method. If I actually started with integral from a to b of f prime of x dx, I could take the derivative of this, right? Like that. And what I would essentially be doing would be taking the derivative with respect to x on the other side as well. So I'd have f of b minus f of a. Now, if a and b were constants, then f of b would be a constant there, and f of a would also be a constant there. And so essentially it would be 0 equals 0. It's quite meaningless in this case. So what we're going to do is we're going to switch out this dx, and we're going to switch out the bounds of integration. So we'll be a little bit more clever, and let's start with this. If we were to have the integral from a to x instead, we would have f prime of perhaps something like t dt. Now, using this part over here, the fundamental theorem of calculus part two, like this, I should end up with f of x minus f of a, right? So that's essentially what I should be ending up with. But now notice that this first part is a function of x, whereas this is just some sort of constant, right? You're taking f, evaluating at a. So if I were to now take the derivative with respect to x of this integral over here, f prime of t dt, then that would be the same thing as taking the derivative with respect to x of f of x minus f of a. And lo and behold, this part right here actually just becomes f prime of x. So essentially, we write this kicker over here, derivative with respect to x of the integral from a to x of f prime of t dt is equal to this right here. So let me highlight them for you. We'll use a white highlighter. So like this and like this. These are the two fundamental theorems that you actually have. Now, there is a twist to this form over here, where sometimes they want you to apply chain rule. So they'll be really, really tricky, and I'll show you how that might work. They might want to integrate from g of x. So notice in this lower bound, that's actually a function of x, to h of x like that. And of course, they'll still do f prime of t dt. So according to our first rule over here, this is pretty straightforward. This just becomes f of h of x minus f of g of x, just like that. So if we were to then take the derivative on the left-hand side with respect to x, we would have to take the derivative with respect to x on the right-hand side as well. And so if we were to calculate this, we could rewrite the whole thing. So derivative with respect to x of the integral from g of x to h of x of f prime of t dt. Then that over here should just equal, well, if we're taking the derivative of this composition of functions, we have to use the chain rule. And similarly, if we take the derivative of this over here, we would also have to use the chain rule. So what this becomes is just f prime of h of x, like this, times h prime of x. And I would subtract f prime of g of x times g prime of x. And so that is your fundamental theorem of calculus with the two parts and a little variant thrown down below. All right, so let's go ahead and stop there.